Hello dear students, Assalamu alaikum. Today I'm going to solve some questions related to Pulley of Cambridge AS Maths Mechanics. This particular problem is taken from summer 2022, May-June 2022, Folk 2, question number 3. So at first let's go through the question properly. Two particles A and B of mass 2.4 kg and 1.2 kg are connected by light inextensible string which passes over a fixed smooth pulley. A is held at a distance of 2.1 meter above a horizontal plane. So let's consider this is the horizontal plane. Say for example, A is here and it is 2.1 meter above the ground. And B is 1.5 meter above the plane. Meter above the plane. And here's the pulley. Here's the pulley. The particles hang vertically and they're released from rest. That means initially it is held like this in this position, then you are releasing it. In the subsequent motion, A reaches the plane and doesn't rebound, and B doesn't reach the pulley. A will reach to the ground, but it won't rebound, and B is not going to reach to the pulley. I mean, A will fall down, A will reach the ground, and it's not going to bounce back. And as A is descending downwards, so B will move in upward direction, but B is not going to touch the pulley. So that's the condition of the math. So we need to find out the tension. Show that the tension in the string before A reaches the plane is 16 Newton and find the magnitude of the acceleration of the particles before A reaches the plane. So we need to find out the acceleration, and at the same time, we need to show that the tension is 16 Newton. Now, at first, let's find out the corresponding Newton's second law equation. Like, let's consider object B. The weight of the object B is acting in downward direction, and there will be a tension in the wire. According to Newton's third law, it should act in upward direction. So let's consider it as T. In case of A, weight will act in downward direction, and according to Newton's third law, tension is going to act in upward direction. So for B, if we consider just B, so as A is moving downwards and B is moving upwards and B is accelerating in upward direction, so that means the tension on B is greater than the tension of the weight of the B. As B is accelerating in upward direction, A is descending downwards, B is moving in upward direction. So the tension that is acting on B has to be greater than the weight of B because it is accelerating in upward direction. So T is greater. Weight of B is comparatively smaller. Mass of B and acceleration A. You don't have to write like this. You can directly write down the values. I'm writing like this so that you can understand. All right. So T minus weight. So that means mass of B was 1.2 kg. And the mass has to be multiplied by G. So that's our first equation. Now let's consider A. For A is descending downwards, so weight of the A has to be greater than the tension that is acting on the string on the part where A is suspended, right? So weight of A minus tension equals to mass of A into G. So weight is 2.4 G minus tension equals to 2.4. Sorry, it's not going to be G, it's going to be A. 2.4. So that's second equation. Now we need to solve them simultaneously to find out the value of tension and acceleration. We're adding them. So if we calculate, the acceleration is going to be, the value of g is 10. So 1.2 into 10 by 3.6, which is going to be 10 by 3 meter per second square. So that's the acceleration. And you can put the value of that acceleration in any equation 1 or 2 to find out the corresponding value of tension. So from 1, tension minus 1.2 into 10 equals to 1.2 into 10 by 3. If you make t as the subject, the value of t is going to be 16. So very simple. So this is a very common question. I mean, if you see any Pulley related maths, in most of the maths, in the first question, the question is going to ask you to find out the value of tension and acceleration that is acting on the system. So this is pretty common and not that difficult. I hope you have understood. So let's move on to question B. Find the greatest height of B above the plane. Find the greatest height of B above the plane. So for understanding the context of this question, I've drawn the diagram again. So here you can see that the particle A and particle B, that was the initial position of both the particles, and A prime and B prime, A prime and B prime is the position of the particle after when we have released the system. All right. Now what will happen? A will descend by 2.1 meter and B will ascend by 2.1 meter, because the amount of distance A is going to cover in downward direction, the same amount of distance B is going to cover in upward direction, which is 2.1 meter. Now think about it. As A is moving downwards, it is accelerating and it is gaining speed, and B will also gain speed because they're connected particles. So the velocity, the change in velocity of both A and B is going to be happen in similar way. All right. Fine. So now, when A is going to touch the ground, just before touching the ground, it will have a velocity, say for example, VA. And B will move from here. B will move from here to here. And here the velocity, let's consider the velocity is VB. So the value of velocity of VA and VB is going to be equal. So let's find out that velocity because that's important. So for A, we know about the acceleration. Acceleration of the system was 10 by 3 meter per second square. So we can easily apply the formula V square equals to U square plus twice X. The system was released from rest, so the initial velocity was 0. Acceleration was 10 by 3. And displacement is 2.1 meter. So from here, the velocity is going to be, let's calculate it. The velocity is going to be root over 40 meter per second. So that's VA. And VB will also be root over 40 meter per second. Okay, now what will happen? So when A is going to touch the ground, the tension on the string provided by A won't be anymore. Why? Because A has touched the ground. So the tension on the string is going to be released from the side of object A. And as a result, you have to be careful. That means the weight of A was greater than weight of B. So that's why A was creating tension in the string. And as a result, object B was moving in upward direction. And the tension on the string on the side of A was happening because of the weight of A, which is acting downwards. But as A has touched the ground, so it won't be able to create any tension on the wire. As a result, after reaching to that point, then as B was having some velocity, root over 14 meter per second, because of that velocity and because of inertia of motion, it will still move in upward direction. But now the acceleration that is going to act on the object is going to be just acceleration due to gravity. So from using that by using that information, we can find out how much distance B is going to cover in upward direction from here. So from so now we can apply the formula v square equals to u square minus twice a. So, I mean, this is for object B. Why? Because the object is going to move in opposite direction to gravitational field strength. The gravity is acting in downward direction, but the object is moving in upward direction. So that's why the acceleration is going to be negative acceleration. So from here, B will reach at a certain height. We don't know the height. We will find it out now, but it's not going to reach the pulley. That information is given in the question. So final velocity is 0. Initial velocity is root of acceleration is acceleration due to gravity, that is 10. So from here we can find out this. The value of S is going to be 0.7 meter. The question was find the greatest height of B above the plane. I mean, what is the distance of B from here, from the plane? So that's going to be 1.5 meter plus 2.1 meter plus the amount of additional height the B is going to move in upward direction, that is 0.7 meters. So you need to add all of them. So the height of object B from the ground is going to be, initially it was already 1.5 meter. Then it has moved up 2.1 meter. Why? Because A was descending downwards by 2.1 meter. And then again, because of the inertia of motion, B will again move additionally 0.7 meter. So if we add all of them, the answer is going to be 4.3 meter, and that will be the final answer. Okay, fine. Let's move on to the next question.